Good evening, dear students. Today we will be discussing parabola. Um, this is a continuation of our class in conic section. If you recall that in our last class we discussed about the conic section, introduction to conic section, and what are the different conditions to be satisfied in the general equation of second degree so that it qualifies to be either a parabola or ellipse or hyperbola like this. Now, before I proceed further, could you please confirm that you are able to hear my voice very clearly and able to view the screen properly, dear students? Could you please confirm?
Yes, sir.
Okay, great. Thank you very much for the confirmation. Now, let us first understand that what is parabola. Parabola is nothing but a locus of a point. Okay, so and the locus of a point subject to some geometrical conditions. What is that? A parabola is the locus of a point which moves in a plane so that the ratio of the distance from a fixed point and its distance from a fixed straight line, okay, is equal to 1. And here is one condition, that the fixed straight line is not passing through the fixed point S. Whatever I said, dear students, okay, let me write it down from the study material so that you get a clear idea, and then we'll discuss about it further. So, what you see, the equation of a parabola is something like this. A parabola is the locus of a point P. So we are considering the point as point P. It is the locus of the point P. Suppose this is the point P, which moves in a plane so that the ratio of the distance from a fixed point S, this is the fixed point S, and its distance from a fixed straight line, that is the fixed straight line, okay, subject to the condition that the fixed straight line is not passing through the fixed point S, is equal to 1. That means what is the a distance between the that point P and the fixed point, that is PS. And what is the distance from the point P to the fixed straight line? It is actually the perpendicular straight line, that is PM. That means from the point P, if you draw a perpendicular to the fixed straight line, and if M be the foot of the perpendicular as you see in the diagram, then we called the distance between the point P and the straight line is PM. So what we see here is that SP by PM is equal to 1. Okay, so what we get, dear students, if I write it here, that SP by PM is equal to 1, and this is the condition to be satisfied to say that the locus of the point P, that means the curve traced by the point P, is a parabola. Correct, dear students? So this is the required condition so that the curve traced by the point P qualifies to be a parabola. That the ratio of its distance from a fixed point, that is S, okay, that is SP is the distance between the fixed point and that point P. P is a variable point because P is varying, but it is varying in condition that its ratio of the distance from a fixed point, that is PS, and divided by that PM is equal to 1. PM means the perpendicular distance from that variable point to the fixed straight line. So SP by PM is equal to 1, and then we called that the curve thus traversed is a parabola. So now we are going to get some terminologies here. Okay, what are the terminologies? These are the name. The point S is called the focus of the parabola. Okay, so let me first write it down, and then we will we will discuss in details. Okay, in case I hope the screen is visible. So if you see, dear students, the fixed point S, that is this fixed point S, is called the focus of the parabola. So this fixed point is known as the focus. The fixed straight line here, that is the line passing through the point M and perpendicular to PM, is called the directrix. So this straight line is known as the directrix. Okay, that is the first 2 points we discussed here, students. The third point, the straight line passing through the focus S and perpendicular to the directrix of the parabola is called the axis of the parabola. Let me repeat, the straight line passing through the focus and perpendicular to the directrix is called the axis of the parabola. So dear students, if we need to draw the axis of the parabola in this one with blue color line, so this will be a straight line which passing through the point S, that is the focus of the parabola, and perpendicular to the the directrix. So it looks like perpendicular. Let me draw it properly. Yeah, this is the blue line. What you see, dear students, it is actually the axis of the parabola. I hope it is clear, dear students. The third point, the point of intersection of the parabola with the axis of the axis is called the vertex of the parabola. I repeat, the point of intersection of the parabola with its axis. The point of intersection of the parabola with its axis is called the vertex of the parabola. We will see when we'll draw the curve of the parabola. This particular point we will see it later. The straight line passing through the focus and perpendicular to the axis of the parabola is called the latus rectum of the parabola. So dear students, if I want to draw the latus rectum of the parabola with this, the diagram, what you see, so and in the green color, so what it will be, let me read the statement and draw accordingly. The straight line passing through the focus here is and perpendicular to the axis of the parabola. What is the axis of the parabola? That is the blue line, as you see, dear students. So now it is perpendicular to that one. So just a minute, let me draw the line, and perpendicular to the axis of the parabola and passing through the focus. So the green line, dear students, what you see, that is called the latus rectum. So dear students, what is latus rectum? This particular green line, that is known as the latus rectum. Latus rectum. And the blue line we discussed earlier, that is known as the axis of the parabola. Axis of the parabola. Correct, dear students? Now, what we are going to do is that, I am going to, take you to the general equation of the parabola, and let's see how it actually being done. So the first one is that, this is coming under the discussion of different forms of parabola. The first we are going to discuss about the general form. Okay, so general form of parabola, how it looks like. So that we are going to discuss in details. That discussion is very important so that you have a very clear understanding about the different attributes of the parabola. Different attributes means that its focus, the vertex, the axis, the latus rectum, the directrix. Okay, all these things will be very crystal clear. The moment we derive on that, from that general equation, from the general form, so our idea of the parabola will be very clear. After that general form, we'll come to the standard form, which is very frequently used. General form is not very frequently used, but I discussed the general form and derived the equation. So so that you have a very clear idea about that how the equation of a parabola is actually formed, how we derive the equation of the parabola. In that context you can see that, okay, as if that we are actually finding the locus of that point P, locus of that variable point P, which keeps a the ratio whose distance, ratio of that variable point distance from a fixed point, which is the focus, and the fixed straight line, which is the directrix, is equal to 1. And we just want to derive that one. So that is why I give you this background information, dear students, so that you will understand that why sir is actually very interested to derive the general form. So let me first draw the diagram and then explain one by one. If you look into, dear students, this particular diagram. So if you look into it, this curve, this is the equation of the parabola. What I am arrowing actually, this is the parabola. This is the required parabola. Okay, this is the required parabola. Now, if you now just go through the statement what we have just learned in few minutes back. So S is the focus of the parabola. Okay, this is the focus, and let's assume that coordinate of the focus be h comma k, and d1 d2, as you see, dear students, that is the directrix of the parabola. Correct? So d1 d2 is the directrix, and let's take its equation as lx plus my plus n equal to 0. So what is the equation of this straight line is lx plus my plus n equal to 0. Let me write properly. Sometime in the digital board it is a little difficult to write. Lx plus my plus n equal to 0. This is the equation of the directrix. So dear students, these are the two fixed attributes. One is the focus, which is fixed. For a particular parabola, dear students, focus cannot change, directrix cannot change. Okay, focus is fixed, which we took that coordinates as h comma k, and the directrix d1 d2, that is a fixed straight line, and its equation we took the general form like lx plus my plus n equal to 0. Correct, dear students? I hope it is clear. So I'm just writing, as I said, that let S be the focus. Let me give you the write-up here, dear students. Okay, as you see, so let S be the focus of the parabola with coordinates as h comma k, and d1 d2 is the directrix of the parabola with equation as lx plus my plus n equal to 0. Then, dear students, let's take the point P. P be any arbitrary point, because the point P is varying, right? So P is an arbitrary point with coordinate alpha comma beta. Its alpha beta is changing. Okay, what you need to do, we need to find the locus of the point alpha beta, which is nothing but the equation of the parabola. So dear students, so what is our objective here? Objective here is that, find the equation of the parabola, and for that, what is the variable point? Here the variable point is the point P. Point P is the variable point here, and we need to find the equation of the parabola, or on the other hand, we can say we need to find the locus of the point P alpha comma beta. Okay. So now let's see how we can derive this thing. One thing we are pretty sure, dear students, is that the distance between the point P and S and should be equal to the distance from the point P to the straight line d1 d2. Correct? That is the condition. That is the geometrical condition. Let me again revisit quickly. Same statement I am repeating, because if I repeat this, it will be very clearly stays in your mind. What is the equation of a parabola? What is a parabola? A parabola is curved traced by a point so that the ratio of its distance from a fixed point, that is S, that is SP, and the ratio of its distance from a fixed straight line, that is d1, d2, and the distance is pm, should be equal to 1. So sp by pm is equal to 1, correct, dear students? So what we get? So for the equation of a parabola, we get that sp by pm is equal to 1. That means what, dear students? That means sp is equal to pm, correct or not? That means sp is equal to pm, and eventually as sp and pm are the length of line segments, so their square should also be equal to 1. That means sp square is equal to pm square. Now, dear students, we know the coordinate of the point S, that is h comma k, and we know the coordinate of the point P, that is alpha comma beta. Now it is pretty simple to find sp. What is sp then? Sp should be alpha minus h whole square plus beta minus k whole square. And what is pm? Pm is nothing but, if you recall our straight line discussion days, that is the length of the perpendicular drawn from a point P alpha comma beta to the straight line Lx plus my plus n equal to 0. How to do? L into alpha plus m into beta plus n by square root of L square plus m square. So dear students, if we just write down whatever I said, it looks like something like this, and I hope you agree to me, correct? If you see that sp is something like this, sp is nothing but square root of alpha minus h whole square plus beta minus k whole square. Now we make a square of this, so sp square becomes this, the entire thing, this entire thing, okay? And what is pm square, dear students? Pm square is this thing, because that is the length of a perpendicular from a point to a straight line, and length of the perpendicular we know, that is Lx plus my plus n, that is the equation of the straight line, dear students. So you should replace x by alpha and y by beta, that is L alpha plus m beta plus n, that complete whole square, that if we make that pm square divided by L square plus n square. So now with this, we are able to understand why I wrote this equation. Now all you need to do, dear students, is that whatever I wrote, we need to just simplify. And if we simplify, dear students, that we are going to get something like this sort of equations. It is just simply algebraic simplification. I just take it from from the study material, and let me show it to you, rather than me writing each and every step, because it is so simple, but it is a little elaborate. Okay, if you look into it, this is the equation. This is the equation we are going to get. That is, if you see after rearranging everything, so you will get something like this, and after further simplification you will get like this. You can do it at your end and you will get it like this. Now what is our target? Our target is to find the locus of the point P. That means what? That means we need to replace alpha by x and beta by y. That is the way we know how to find the locus of a point. To have a very great idea about the locus, you can always go back to in the online platform and look into our lecture, Konar classes lecture on locus. Also, you can go to YouTube and find that lectures, great lectures are available on locus. So now, if you look into this, above equation 1, so we can find the locus of the point alpha beta just by replacing alpha by x and beta by y, isn't it, dear students? So I'm going to get that the general equation of the parabola is something like this, and I'm going to show it to you now. Okay, dear students, so from the above identity 1, we get the locus of the point P, alpha comma beta, that is the required equation of the parabola as below. We just replace alpha by x and beta by y, and we found that one. Correct, dear students? Now, what I'm going to take you to the general equation of second degree in x and y. If you recall, the general equation of second degree in x and y, what is that, dear students? It is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So now I want to make a one-to-one correspondence with this equation, what you see in the equation 2, with the general equation of second degree in x and y. And let's see what we are going to get out of it. So, dear students, as you see the equation 2 and my statement here, let me read it out so that you get exactly what I'm saying. We see that the above equation 2 is of the form of general equation of second degree in x and y, like ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So this equation and this equation, okay, if we equate the like terms, then what we are going to get? Equate the like term means that coefficient of x square in equation 2 and coefficient of x square in the general equation, that is a, then you will get a equal to m square. Similarly, the coefficient of xy, or coefficient of 2xy in equation 2 and coefficient of 2xy in the general equation of second degree, will get h is equal to minus l into m. In that way, the other like terms, if we equate, we'll get this thing, whatever you see here, dear students. Now, if you recall, why I'm always telling that if you recall, because before this class of parabola, we discussed about that conic section, that under what condition a general equation of second degree in x and y qualifies to be an equation of a parabola. If you recall, that condition was that the delta, the determinant, should not be equal to 0 and h square should be equal to ab. That we discussed during the generic discussion of conic section. You can go back to that discussion. Video lectures is available both in YouTube and in the online platform. You can look into it and you will get a very clear idea. So if you make that comparison, what you are going to get it, dear students, you will get that the delta, I'm just going to place it here. You'll find that delta is equal to 0. Delta is nothing but ABC. There is a style of writing, if you recall, that from the general equation of second degree, there is a style of writing the determinant. So if I'm just underlining this general equation of second degree in x and y, and from there, how we can find that value of delta. In my previous few classes, I I showed you that how to write it down. I'm just writing once more, because if I repeatedly do, it will be staying in your mind clearly. So you'll write A, B, C in the diagonal, then F, G, H. In the same manner, you write F, G, H. That means, as if, dear students, that along that ABC, if you place a mirror, and whatever the FGH you wrote in the top diagonal triangular fashion, it will actually come in the bottom. Correct? No? That is the way to write it down. And if you find that value of delta with respect to this equation 2 by applying the value of A, P, C, F, G, H as you get it here in this one, you will find that that determinant is not equal to 0. And also you will see that h square is equal to AB. H square equal to AB in context to our discussion, that is equal to L square into M square. So dear students, with this we are able to understand that how the generic form of a parabola looks like. The generic form of a parabola, the equation, if I just say once more, the generic form of the parabola is with focus at the point h comma k, and the directrix is having the equation Lx plus my plus n equal to 0. Then the equation of the parabola will be like this. And we derive from a very fundamental the condition satisfied by parabola, that is the geometrical condition. I repeat, what is that condition? The ratio of that distance of any point on the parabola from a fixed point and from a fixed line, that is equal to 1. That ratio is 1, and from there we actually able to derive this thing. Correct, my dear students? I hope you got it. But the point is that this equation, what I wrote in that in the blue box, is not very commonly used. what commonly used is that is called the standard form, and that's what we are going to discuss now. And standard form of parabola is actually widely used. Questions are coming from there also. But why I then discuss about the generic form? Because so that you get a very clear idea that how that equation actually being formed by not taking any kind of a restriction on the coordinate of the focus or restriction on the equation of the directrix. You see, what we took in the generic form, coordinate of the focus we took as h comma k, a very generic point. And what is the equation of the directrix? Lx plus my plus n equal to 0. That is also a very general form of an equation of a straight line. But in standard form, dear students, we will restrict. Okay, and that I'm going to discuss with you. So then our next point of discussion, dear students, is the standard form of equation of a parabola. And that I'm going to discuss in the next page. Okay, so you see that I wrote the header as standard form. Let me first show you how it looks like the standard form. If you look into the standard form, you will find, oh, it is much more simpler than the generic form. Let me first show you, dear students. Yeah, this is the standard form. If you see that that parabola is something like this. I'm just giving an arrow that both the end is arrow, because it can expand in both these directions. So now the point is that the point is if you see that focus that is at the point a comma 0. This is our x-axis. You see, this is our y-axis. So now how we are restricting the focus? Focus is at point a comma 0. And directrix is d1, d2, this straight line, dear students. You see, it is actually, perpendicular to the x-axis. What does it mean? It means that axis of the parabola is actually the x-axis. Correct, na? You can always go back to this video. I'll share this video lecture after once our class is done. So when you discuss about the attributes of a parabola, that is focus, directrix, then the vertex, then the axis of the parabola, then latus, rectum, all these things, if you go through, then you will find what is the vertex of the parabola. At that time we didn't discuss in details. This is the vertex of the parabola. Okay, as you see the point A, which is coinciding with the origin of the coordinate axis, means the intersection of the x and y axis. Okay, dear students, now this is a standard form of a parabola, and what we are going to do, we are going to derive the equation of it, and you will see it is much more simpler to derive this one. So as you see, let S be the focus. Let me write down the statement, dear students. Okay, and then I will go through this statement. Okay, so here is the statement, and let us go through it together. Let S be the focus of the parabola, and d1, d2 is the directrix of the parabola. Let P be any point on the parabola with coordinates alpha comma beta. We need to find the equation of the parabola, that is the locus of the point P alpha comma beta. That is what we need to find it out. That we need to find the the locus of the point alpha comma beta. Correct, dear students? So how we are going to find it out? As you understood that the generic form, it will be very simple. And let us now draw the line SZ as you see it. As you see that we are, let us draw the line SZ perpendicular from the point S to the directrix D1, D2, where the point Z is the foot of the perpendicular from the point S to the directrix D1, D2. The straight line SZ is known as the axis of the parabola. Okay, so let me write it down. And you'll able to get it very clearly, dear students. And if any smallest doubt, never hesitate to let me know. So as you see, what I wrote there is that let us draw the line SZ perpendicular from the point S to the directrix D1, D2. Okay, where the point Z is the foot of the perpendicular from the point S to the directrix D1, D2. The straight line SZ is known as the axis of the parabola. Let me complete the statement here as I am taking it from the study material. So what I can say here is that this is the one. SZ is known as the axis of the parabola. Now the middle point of SZ, you see the middle point of SZ, that is the point A, will lie on the locus of the point alpha beta, that is AS by SZ should also be equal to 1. Let's focus on this particular point. Let's concentrate on this particular point. If you look into that point A, that point A is also on the parabola, na? So then it should also satisfy the definition of the parabola. What is the condition laid for parabola? What is that? That its distance from a fixed point, that is AS, okay, should be equal to its distance from the fixed line, that is D1, D2. Now, if AZ is the a perpendicular distance from the point A to the directrix D1, D2, and AS is the distance between the point A and the focus S, then definitely AS by AZ should be equal to 1, and eventually we get AS equal to AZ. Correct, dear students? Got it? So now let us now select the point A as the origin O, the x-axis along AS, and the line y-axis along the perpendicular to the AS at the point A. Correct? Now, how we are choosing? Let us now select the point A as the origin. That means the point A and point O, that is the origin of the Cartesian coordinate system, are actually coincide. The x-axis along AS and y-axis along the perpendicular to the AS at the point A. So how it looks like, dear students? If I write down that statement, the statement will be something like this. Correct, dear students? I hope you got it. Okay. Now let us take AS equal to A, because as the focus is at the point A comma 0 and A is the origin, okay, means which is coinciding with the point O, then definitely A is equal to A. If A is equal to A, then definitely AZ should also be equal to A, because we just observed that A is equal to AZ. Correct? So then what we are going to get, the moment you get AZ equal to A, then we can find the value of PM. PM is nothing but it should be alpha plus A. Okay, so let me derive this particular point. Okay, let me take it from the study material and then let me show it to you. Okay, so you may find that the picture is actually, the diagram of the parabola is not visible, but just to make it correspondence with the derivation, let me take that the diagram of the parabola once more in the right hand side, so that you can make a one-to-one correspondence, dear students. Okay, so if you see that AZ is equal to A, as AZ equal to A, so AS should be also equal to A. We know that AZ equal to AS equal to A. So then what is PM? PM is nothing but this distance, which is nothing but alpha, and this distance, which is nothing but this distance is alpha. Correct? And this distance is actually A, so alpha plus A. Correct, na? So what I want to say is that if I write by symbolic some point form, is that from the point P, if you draw a perpendicular to the directrix D1, D2, M is the foot of the perpendicular, and that perpendicular should also intersect the y-axis. Suppose it intersect the y-axis at the point, suppose N. Then Pn is nothing but, what is Pn? Pn is nothing but alpha, and Mn is nothing but Mn, let me write properly, Mn is nothing but A. So what is Pm then? Pn plus Nm, that is alpha plus A. That is why Pm is equal to alpha plus A. And what is Sp? Sp is nothing but the distance between the point P with coordinate alpha comma beta and the point S with coordinate a comma 0. So then what we get, Sp square is equal to, Pm square. So that means alpha minus a whole square plus beta minus 0 whole square is equal to Pm square, that is alpha plus a whole square. This one. And if you simplify, then you'll get something like this. Beta square is equal to alpha plus a whole square minus alpha minus a whole square. Dear students, a plus b whole square minus a minus b whole square, we know that it is equal to 4ab. And eventually we get that beta square is equal to 4a alpha. That is a very important, derivation. Beta square is equal to 4a alpha. Now what is A? A is the, x coordinate of the focus S. That means it is constant. It is fixed. Why it is fixed? Because we know for a parabola, a focus is fixed point. So definitely its coordinates should also be fixed. So if A is fixed, 4A is eventually fixed. So then locus of the point alpha comma beta is nothing but, in that equation, that is beta square equal to 4a alpha, we just need to replace alpha by x and beta by y. So what we are going to get then, dear students? If we do so, then what we are going to get, the locus of the point alpha comma beta is the equation of the parabola as below, that y square equal to 4ax. Okay, dear students, so what we are going to get it is that, so the locus of the point alpha comma beta is the equation of the parabola y square equal to 4ax, and that is a very important equation. Okay, y square equal to 4ax, you see, dear students, for the next almost 2 years you need to deal with this kind of equation. It is used in application of differentiation, it is used in tangent normal, it is used in coordinate geometry, and also in physics. Okay, it is also used in when you discuss about the projectile motion, there also it is used. So this is about the equation of the parabola. Now, dear students, there are, if you see the equation of the parabola, that y square equal to 4ax, the axis of the parabola is the x-axis. Correct? Now, it may possible the axis of the parabola could be y-axis also. Okay. Now, what will be the different orientation of these parabolas? What will be the look of this different parabola? That I want to show it to you, dear students. Okay. For that, I just want to make some little drawing, and you will see that, and different color I will draw, and it will be very well understood by you. So, dear students, so first I am going to draw the coordinate axis. Let me draw the coordinate axis in the black color. Okay. At any point of time, anything, if you have any smallest question, never hesitate to ask me. So this is the x-axis, positive direction. This is the negative direction x-axis. This is positive direction of y-axis. This is negative direction of y-axis. And this is the origin. Now first I want to draw the parabola corresponding to the equation y square equal to 4ax. And that I am going to draw in the red color, dear students. So my drawing is not that great, but you understand what I wanted to mean. So this equation, what you see, dear students, that is y square equal to 4ax. Whatever you see in the red color, the curve I have drawn, that is actually a parabola whose equation is of the form y square equal to 4ax. Then definitely, dear students, what will happen if I draw a parabola having, in this parabola, the red color what I have drawn, what is that? Positive x-axis, ox is the axis of the parabola. Now if we do the y is the axis of the parabola, so what will be the parabola will looks like? The parabola will looks like something like this, isn't it, dear students? So this parabola equation will be equal to x square equal to 4ay. X square equal to 4ay. Minutely look the difference, dear students. In the red color, where the ox is the equation, ox is the axis of the parabola, the equation of the parabola is of the form y square equal to 4ax. But when we see that axis of the parabola we consider as oy, you just need to replace x and y, dear students. So y square equal to 4x. If you replace y by x and x by y, what you'll get? X square equal to 4ay, and that's what you get. Correct? Now another point is that whatever you see in the red color, okay, if we take exactly the flip of that one in the green color, so what it will be, dear students? So sorry, I need to draw it properly. So what I wanted to mean, if this is the equation of the parabola, then what it will be? Equation of this parabola should be y square equal to minus 4ax. Correct? And in the similar manner, if we take, the blue color, what you see is that x square equal to 4ay. If we take a flip of it, that means the blue color parabola having the axis oy. Now if we flipped it, it will be downwards and it axis will be oy dash, and let me draw it in a purple color. So the its equation will be something like this. Correct now, dear students? So it should be x square equal to minus 4ay. So these are the four different types of equation of the parabola. The red color is y square equal to 4ax. The blue color is x square equal to 4ay. The green color is y square equal to minus 4ax. And the purple color is x square equal to minus 4ay. Okay. Now, for each of these equations, you will have a different directrix, different focus, okay, different latus, rectum. All these attributes will be different. Only one point is common, that is the vertex. Vertex is at the origin for all these parabolas. So now for these different attributes of these parabolas, I just want to show you the following table. And if you remember this table, that will be actually very good, and you will be able to answer almost any question related to the fundamentals on the parabola. Okay, so so what I said, dear students, and I just explained by means of this diagram in four different parabolas, that depending on the selection of the coordinate axis and standard form of a parabola and its different attributes like coordinate of the vertex, coordinate of the focus, equation of the directrix, equation of the axis, length of the latus rectum, all will get changed. And it gets changed in a very, by following a proper pattern. And I want to show you that particular table, and I also let you know that how this pattern is actually getting formed. Okay, dear students, and that I'm going to show you here in this table. Let me see whether it fits in this table or not. Yeah, it actually fits in this table. So good. So what I say is that, dear students, is that if you look into this, if I make this in the full screen. So now depending on the selection of the coordinate axis and the standard form of a parabola, okay, and its different attributes may vary as shown. So if we take y square equal to 4ax, then coordinate of the vertex is at the point 0, 0. Coordinate of the focus at the point a, 0. Equation of the directrix should be x plus a equal to 0. Equation of the axis should be y equal to 0. Length of the latus rectum is 4a. What is length of the latus rectum? That I need to tell you a little bit about the length of the latus rectum. Let me explain you by means of that parabola y square equal to 4x, which is drawn in the red color. So, dear students, if you see, this is the focus S, and what is the coordinate of the focus S, a, 0. Now, if I draw a perpendicular, okay, through the point S, perpendicular to whom? Perpendicular to the axis of the parabola, which is OX in this case. if I draw a perpendicular on OX, that is the axis of the parabola, which passes through the point S, then what we'll get? We'll get this is as the latus rectum. Na? So length of the latus rectum is the length of the line segment of this line, what you see in the red color I have drawn, which is intercepted in the parabola. Suppose if this point is L1 and this point is L2, then what we get, dear students, L1, L2 is known as the length of the latus rectum, and that is actually equal to 4a. L1, L2 is known as the length of the latus rectum. So that is what I said here. The length of the latus rectum is 4a. Correct, dear students? So now the different forms of parabola. So if y square equal to 4x, these are the different attributes. Now you take y square equal to minus 4ax, then if you take the y square equal to minus 4ax, dear students, that means which is the adjoining diagram? It is the green color. Correct? What is the coordinate of the vertex? 0, 0. Coordinate of the focus? Minus a, 0. Equation of the directrix? X minus a equal to 0. Equation of the axis? Y equal to 0. And length of the latus rectum is 4a. Now, if we go, you go to the next one, that is x square equal to 4ay, which is in the adjoining diagram is the blue color. Where the axis is OY, then what is the equation of the, what is the coordinate of the vertex? 0, 0. What is the coordinate of the focus? 0, a. Equation of the directrix is y plus a equal to 0. Equation of the axis is x equal to 0. And length of the latus rectum is 4a. In the similar manner, if we look into the next one, that is the last one, standard form, that is x square minus 4ay, x square equal to minus 4ay, which is the curve drawn in the left hand side in the purple color. If you see, dear students, what is the coordinate of the vertex? 0, 0. Coordinate of the focus is 0, minus a. Equation of the directrix is y minus a equal to 0. Equation of the axis is x equal to 0. And length of the latus rectum is 4a. Correct? Now, dear students, I want to discuss that if we make the vertex is not at the point 0, 0. Suppose vertex is at the point alpha, beta. Okay, and the axis of the parabola is parallel to the x-axis, with the length of the latus rectum is 4a. By the way, one point I didn't say, but let me now tell you, is that whenever you see that y square equal to 4ax, that 4a, the coefficient of x, is known as the length of the latus rectum. So what does it mean? It means is that if I get an equation, suppose y square equal to 3x, then what is the length of the latus rectum? Is 3 units. If you get an equation, suppose you get an equation something like this, in the purple color I am writing that x square is equal to minus 7y, then what is the length of the latus rectum? Is 7 units. Minus we are not taking because it is the length of the line segment, it should be positive, that's why it is 7 units. Got it? So like this, the coefficient of the right hand side variable is actually the length of the latus rectum, ignoring the sign, negative sign. Okay, now what I wanted to mean is that let me first write it down and then let me followed by its explanation. So please note the following points is that the equation of a parabola with vertex at the point alpha, beta, with its axis as parallel to x-axis and the length of latus rectum is 4a, is y minus beta square is equal to 4a into x minus alpha. Okay, let x minus alpha equal to capital X and y minus beta equal to capital Y, then the equation of the parabola, that is y minus beta whole square equal to 4a into x minus alpha, it reduces to capital Y square equal to 4a capital X. The center of such parabola is at 0, 0. All other attributes can be obtained by replacing lowercase x by capital X and lowercase y by capital Y, uppercase Y, in the form y square equal to 4x. That is the first point I wanted to mention. Second point is that the equation of a parabola with its axis parallel to x-axis is generic equation is x equal to ay square plus by plus c. And the equation of a parabola with its axis parallel to the y-axis is y equal to ax square bx plus c. Okay. Now, if you recall, the quadratic equation ax square plus bx plus c equal to 0. Okay, and during that discussion, we see its characteristics of the different roots. Then we draw the corresponding curve, that is y equal to ax square plus bx plus c. It was nothing but a parabola. If you go back to those discussion of quadratic equations, that all the video lectures are available, you will get it that how it actually makes sense. Okay, so with this, I would like to conclude the class for today, dear students. In our next class, we will discuss about the parametric form of parabola. Then we will discuss about the focal chord. Then we will discuss about the focal distance. Followed by, we will discuss about the position of a point with respect to a parabola, tangent of parabola, normal of parabola, pair of tangents from an external point, chord of contact in terms of middle point, and subsequent properties of parabola. So with this note, I would like to conclude the class here, dear students, unless you have any specific question. Thank you very much.
Thank you.
Thank you.